Thanks for joining me on another adventure. I'm Annie Crawley, also known as Ocean Annie, an underwater photographer, filmmaker, and ocean explorer. Sharks and rays are my favorite ocean animals. Today, we are going to explore what makes a shark. Film nurse sharks in a state of tonic immobility. Swim with hundreds of hammerhead sharks. And experience many more surprises. Although there are 5 names for different parts of the ocean basins, we really have only one interconnected ocean. Sharks and rays live all around the world throughout our one world ocean. Some sharks and rays are territorial and will stay in one place all their lives, while other sharks migrate and travel thousands of miles around the sea. Scientists track sharks and rays with satellite technology. There are more than 500 different species of sharks. Most of them are smaller than you. Nearly 50% of shark species grow less than 3 feet long. Sharks live in water throughout the ocean. They are found in every environment, from cold water to tropical water, and even in the deep sea. Sometimes sharks are even found in rivers, but that is very unusual. Sharks breathe with their gills. That is another reason we know sharks are fish. Sharks, rays, and all fish use gills to breathe, removing oxygen from the water. Do you see the slits on the side of their bodies? These are the shark's gill slits. Sharks have 5, 6, or 7 sets of gills. Because sharks live in water, have fins to swim, and breathe with gills, we know sharks are fish. Let's watch sharks as they swim. Sharks use their body and tail in a side-to-side motion to move through the water. I like scuba diving and filming behind sharks because I get to observe them up close. Sharks have segmented swimming muscles that squeeze and contract alternately on each side of their body, causing a wave-like action from head to tail. Other fish that use their fins to swim can move in a variety of ways. But sharks cannot move backwards because they swim with the thrust of their tail always in a forward motion. They can move up and down by using their bodies and fins, yet they cannot stop in one place, hover, or move backwards. The shape of a shark's tail helps us understand more about how different kinds of sharks live. Sharks that dwell on the bottom, like nurse sharks or horn sharks, have different shaped bodies and tails than those that are pelagic, which means living in the open ocean. The shark's tail provides thrust or push, so speed and acceleration of sharks depends on the shape of the shark's tail. Can you see the difference in the shape of these sharks' tails? The short fin Mako shark is the fastest shark in the ocean. it has been clocked at nearly 50 miles per hour. We learn a lot about how sharks live from the shapes of all the shark's fins, not just the tail fin. Let's take a moment to look at all the different fins on a shark. Sharks do not move their pectoral fins like other fish for propulsion. The front edge of a shark's pectoral fin is thicker, and the rear edge is thinner. So water flows over it more easily, like an airplane's wings. Most sharks can only move their pectoral fins slightly up and down. They rely on their fins for balance in the water, so they use less energy swimming. They also use their pectoral fins for steering their bodies left or right and helping them glide up or down in the currents. Using their fins to glide up and down in the water is called dynamic lift. When sharks are in currents, sometimes they will not move their body at all, but will let the currents do all the work. They simply adjust their fins, like they're surfing, riding the currents. Some sharks that rest on the bottom can use their pectoral fins to help them turn too. Dorsal fins, the fins on the shark's back, are used for balance. By observing the shape of the shark's fins helps us identify different shark species. Let's have a look at a few different dorsal fins. The horn shark has a fingernail-like spike on its dorsal fin. This works like an anchor on the rocky reef if there is a surge or strong current. They hook that fin into rocky crevices. Can you see the differences in the shapes of these sharks' dorsal fins? These types of observations help us identify different kinds of sharks. If sharks did not have all their fins, they would not be able to swim the way they do. Because each fin is important in the way they move. Elasmobranchs are very flexible and they have cartilage skeletons. Cartilage skeletons are not as heavy as bone, so their bones are lighter than bony fish, reptile, and mammal bones. Unlike most fish, sharks don't have a swim bladder. A swim bladder is a gas-filled organ fish use for buoyancy. Fish can hover because of their swim bladder. Because sharks and rays do not have a swim bladder, they can't hover. Sharks have a special liver to help them with their buoyancy. The shark liver is usually 30% or more of the shark's body and has something called squalene, which is oily and floats. Although a shark's liver helps them be more neutrally buoyant, they sink if they stop swimming. That is why we can observe sharks either always in motion or resting on the bottom. Some sharks, if inverted or stroked on their nose or belly, will enter a state of tonic immobility. Tonic immobility is a natural state of paralysis that some animals can enter. Researchers and scientists can stop sharks from moving using tonic immobility in order to study sharks more closely without harming them. Scientists believe that tonic immobility may be a kind of self-defense. A shark's breathing and muscle movements become more steady and relaxed in this state. Sometimes sharks will get hooked with a fishing line. If this happens, the hook can get stuck in the side of the shark's mouth. The hook will only come out if we can help the shark. When scuba diving, we need to refrain from touching any animals unless we are working on a scientific expedition. If we want to get close enough to study, photograph, and film the sharks in the wild, we need to move slowly and breathe slowly. Although sharks and rays are in the same class, rays are shaped much different than sharks. Rays do not have the same torpedo-shaped bodies as sharks. Their pectoral fins evolved differently and are shaped like wings. It looks like rays fly in the water. Like sharks, rays always need to swim or they will sink to the bottom too. Manta rays spend their entire lives swimming. Manta rays have gigantic pectoral fins. Just watch these manta rays swimming. They are so beautiful to watch. I love scuba diving and snorkeling with manta rays. The largest manta ray in the world was measured at 23 feet across and weighed more than a ton. Eagle rays are able to surf in currents using their pectoral fins and bodies to keep them in one place. They only can do this in certain currents. They also use their pectoral fins to swim by moving their fins up and down. They sure are cool to watch. When a stingray moves, they also use fins to swim. When stingrays need to rest, they drop to the bottom. You can see stingrays resting along sand flats. Can you see the Stingrays Stinger? They have stingers as a defense against animals that try to eat them. They only use their stinger to protect themselves. Stinger or not, sharks love to eat stingrays. The fish you see around the stingray are cleaning it. They are cleaner wrasse. The stingray lies patiently in the sand as the cleaner fish eats parasites, dead skin, and leftovers from the stingray's gills. Cleaner fish help other fish stay healthy. All fish need to visit cleaning stations, even sharks. Manta rays can swim up to 25 miles per hour. Their long tail has no stingers like other rays, so their only protection are their giant fins and speed. Manta rays are not dangerous, even though they were nicknamed devil rays because of how they look. People thought the cephalic lobes on their head looked like the devil's horns. When swimming, the cephalic lobes retract. But when feeding, they roll them out to help collect and funnel plankton into their mouths. They are filter feeders. Look at the difference in the manta ray when it is feeding and when it is not feeding. Can you see the difference in their cephalic lobes? They have gill rakers inside their mouths, lining their gills for filtering plankton. Although they have small knobby teeth in their mouth, they do not use their teeth for feeding. Manta rays are often found in groups, feeding together in synchronicity during the changing tides, which is when the water in the ocean temporarily rises or falls. The current created by the changing tide is rich with nutrients and plankton. Plankton is microscopic plants and animals making up the base of the food web. Plankton is so small, we usually can't see it with our eyes. Can you see the neon-striped fusilier fish opening and closing their mouths? They are feeding on plankton, the same food as the manta rays. And check out these snappers. As these snappers are swimming in their school, they are opening and closing their mouth. It looks like they are barking. But we know these fish don't bark. They are snapping. They are opening and closing their mouths, sucking in food. They are filter feeding on plankton by snapping their mouth. The snappers swim together in schools for protection, so they don't get eaten by predators like sharks. Bigger fish eat the smaller fish. And then other animals like sharks, dolphins, and human beings feed on even bigger fish. Although plankton can be microscopic, these small little plants and animals are very important. Without plankton, we would not have a healthy, strong ocean food web. Plankton is affected by pollution. In order to have a healthy ocean, we need to keep our environment clean because everything we do on land affects the ocean. There are more than 700 species of rays in the ocean, and electric rays are the only ray that swim like sharks by moving their tails and bodies side to side. Electric rays get their name because when they hunt, they send out electricity from special organs that stuns their prey. By observing a fish's mouth and teeth, we can tell a lot about what they eat. Many sharks are opportunistic feeders and will eat whatever is abundant. They will hunt fish in bait balls, feed on squid, eagle rays, and even queen conch. We know sharks have been around for more than 400 million years. But how can scientists know that? Remember, sharks have skeletons made from cartilage. Cartilage does not fossilize like bones for scientists to study. Sharks' teeth fossilize. One way we know sharks were here before dinosaurs is because scientists study fossilized teeth. Some sharks produce thousands of teeth throughout their lifetime. As they wear down or lose their teeth, new ones simply replace them. Eagle ray and manta ray gills are on the underside of their bodies. Rays take oxygen from the water as it passes over their gills. The round hole you see is a spiracle. This helps some sharks and rays breathe by pumping water over their gills when they are resting. Sharks, without the ability to pump water over their gills, need to be in constant motion. Most sharks are what we call cold-blooded or ectotherms. This means their body temperature is the same as the water temperature that surrounds them. There are a few exceptions, like great white sharks. Great white sharks have a more advanced circulatory system, and they can actually raise their body temperature higher than the water they live in. Animals that can do this are called poikilotherms. Fish sure are different than marine mammals. Sea lions and dolphins have a different type of circulatory system than fish. Marine mammals are warm-blooded. They need to surface to breathe air and cannot stay underwater forever like a fish. Because we are warm-blooded, we need to wear wetsuits if we are scuba diving deep or in the water for long periods of time. Wetsuits help keep us warm in water. When diving in tropical waters, sometimes we only need to wear our bathing suits or board shorts because the temperature of the ocean is much warmer the closer we get to the equator. Some sharks live their whole life in one area on the reef. Other sharks migrate from one part of the ocean to another at different times of year. Their migrations usually have to do with water temperature, food supply, mating, and even giving birth. The actual shape of the shark's body gives us clues to how they live their lives. Many sharks are torpedo-shaped, but other sharks, like angel sharks, are flat like pancakes. Angel sharks spend a lot of time on the bottom camouflaged, resting, or hunting for food. When sharks are shaped to dwell on the bottom, we say they have dorsoventrally flattened bodies. Although angel sharks hang out on the bottom, these sharks can swim too. Scientists classify animals and fish both by what we can observe on the outside of their bodies and what is inside. Characteristics to help classify sharks and rays include shape of fins, size of fins, fin spines, types of teeth, number of fins and gill slits. Can you think of any other ways? What about the color of sharks? Do they have spots or color patterns? Most sharks are gray or brown in color on top and white on their underbelly or underside. We call this counter shading. It's a type of camouflage. When looking up towards the surface or down into the blue, the sharks blend into their surroundings. Other sharks and rays have spots and markings on their bodies. Whale sharks can be individually identified by their spots and stripes. This is the whale shark fingerprint. It's where their ventral fin meets their body. Every single manta ray is identified by a fingerprint too. On the underside of a manta ray is their fingerprint. They usually have white bellies with black spots. But sometimes there are unique animals that have black bodies with white spots. There are worldwide studies identifying whale sharks and manta rays using photographs and video observations. There are unsustainable fishing practices used to take sharks and rays from the ocean. Rays are being targeted and fished for their gills, and people are overfishing these animals. Both of these animals need your help. It is important that we speak out to protect our sharks and rays by raising public awareness in order to create corporate and policy changes. I love sharks and rays and need your help to protect them. You can even get all your friends to dive into their imagination and become ocean adventurers too. Did you know the ocean is still 90% unexplored? I can't wait for you to join me on another dive adventure. So keep diving into your imagination, and until next time, I'll catch you later. To learn more about our amazing underwater world, check out our books, educator guides, and other Adventures of Oceanani programs. You can also email me through my websites, Twitter, Facebook, or YouTube accounts and ask me more about how you can help our ocean.